We'll get started. Good morning, and thank you for attending today's webinar. Amit Nandi will be presenting his webinar, Leverage Simulation to Reduce Product Development Cost and Time to Beat Your Competition. We'll be covering some very interesting topics for you today. We ask that you please mute your microphones and direct any questions you have to the conversation button located on the bottom of your screen next to the hand icon. And now, without further ado, Amit will begin his presentation.
Thank you, Jake. Hello, everyone. Thank you for joining us today. I know that you had many other alternative options to spend your time, but still you decided to spare your next 60 minute of time with us. So I'm really glad for that. So today we are gonna talk about how can you beat your competition by increasing the product development time. I mean to say the reducing the product development time and also the cost. Start from its concept to till the prototyping, right? So let's get started on this. Let me share what are we going to discuss in this particular webinar. So we are going to start out with the challenges during any product development. Either it could be automotive industry or aerospace industry, any industry you can take up. The challenges remain the same in addition to the external challenges what we face as a competition, and why ignoring challenges is a bad option, right? So we should not be ignoring these challenges. So we have to take some actions to correct these challenges or address these challenges. And then what is the way forward to address these challenges, and how do we implement that, and what is our proposition to overcome these challenges and become more competitive in the market with reduced launch time and reduced cost, but still achieving the expected performance of the design. Let's get started now. Right. So if you look at the comparison, or if you plot the graph against how much freedom you have as the design progress. Okay, so if you started out with 0%, you have full uh, freedom where you can change many things. I mean, everything you can change as the design progress. Let's say 5%, 10%, and then 20, 50, 75, and then 100, right? The moment it reaches the design freedom of any change that you want to uh, implement, you will be no longer having that particular those kind of freedom, right? So the later in the design cycle, the less design freedom is left. So whatever you have to do, that has to be well planned in the initial phase itself. But if you do this, like if you want to implement some changes later in the design process, but what happens is, for that particular activity, the cost commitment or the cost estimation will also go high. So as I said, as the design freedom increases, the cost commitment also goes on uh, as the design progress. So let's take an example of the material. Okay, so let's say initially you start out the material by considering steel of your choice, and then at some point of time, let's say after completing 50 or 70% of the design, then you will come to know that if I had selected a different material, let's say composites or any low cost material, which is giving the same performance, which is expected, but entire cost of the product is going high because of the wrong selection or improper selection of the material at the initial level, right? So these kind of small little things which will increase the cost of the product as well as the cost of the development. So this is how, as the progress of the design goes on, you will see less freedom for any change, and you will see a lot of cost commitment as well. So these are all these, I mean, both of these aspects uh, imply a lot on the cost as well as the time. So the big dilemma of in of any product development department or any engineer today is, let's say, once the design is completed by a CAD engineer, he'll pass on that design to a simulation engineer to validate the design, right? With respect to different usage and with respect to different conditions, with respect to different loading conditions, and whether whatever the design has been created that suits the performance requirement or not, right? So for that, it has to go to CA engineer, and then what happens is CA engineer will think of, is it really my problem? Like just whatever the design has come from the CAD department, uh, I'll have to uh, simulate it for just for the validation of strength perspective. Then CA engineer will really think of that, whether do I have to do this first, and then too monotone, and then too time consuming, right? And also he'll assume that there'll not be a further change in the design because let's say he has already started the simulation activity and then he has reached 60 to 70% of it. But what if the CAD engineer comes back and then says, hey, look, this is what the design has been updated, and now we will have to consider this updated design, not the older design. The entire 70% of time which he has spent already is completely a waste of time, right? So and also if you look at the workload, what CAD engineer is having and what CA engineer is having. So CAD engineer, if the CAD engineer is having 1x of the work, then CA engineer will be fully loaded with 3x because he has to execute multiple activities when it comes to the validation, right? With respect to a particular part. So if you look at any component, right, even if it is a single component, so uh, it all starts with when the 3D CAD model is done and needs to be simulated. How should structural analysis be done? So this is what the question arises, and also before this, whether is it really uh, a CAE engineer job or a CAD engineer job? So because if the design keeps on changing, then again the CA engineer cannot spend his time in updating every possible simulation activity, right? So that's how a CA engineer will be spending in non-value added activities. And also everybody knows that CA engineer is a costly resource compared to CAD engineer. So these are the basic dilemmas what each of our product development team or CAD engineer or simulation engineer will be having today, right? So but what happens, let's say, I mean, whatever we discussed about the cost commitment goes on, and the freedom for any change will also get reduced, and there will be so many dilemmas with respect to our CAD engineer and simulation engineers who should be doing what, right? But what if you ignore these challenges? What happens, right? So uh, first thing is the product cost goes high because you keep on iterating design one, design two, design three, and the same thing goes with the simulation department as well. Simulation one, simulation two, simulation three. So the time increases, and the entire product development cost, if you consider per hour basis or per weekly basis, it also goes very high, right? So that's how the product cost also increases. And then the overall development time. So as you are doing to and fro one after another activities, not the concurrent engineering, So that's where you are losing the time. So the entire product development time also goes very high, which consumes a lot of time. And then because of these two things, the launch of the product to the market will get delayed, right? If the product development consumes a lot of time, then again the manufacturing, prototyping, testing, everything will get delayed. So the overall product launch also get delayed. And ultimately, when you are comparing with the competition, then you will lose the market share and also the market size to your competition, right? Because they have already launched the same competitive product to the market, which has already captured the market and known become a known brand to many customers now. So these are the different business implications what we see if these challenges are not addressed or not taken with priority to solve them, right? So what is the way forward now? So here, if you look at the same graph, what we are talking about, uh, you know, in addition to the freedom and the uh, cost goes high, the product knowledge, right? The product knowledge over the period of time during the design progress is also significantly different, right? So this the dotted line says that this is the product information or knowledge increases gradually as the time progress, as the design progress, right? But whereas by doing early simulation, right, that will help you to gain product knowledge early and also take the decisions faster at the initial level itself. Like if you are able to check the material strength either with respect to steel or aluminum or composites, right, in the initial phase, then you will have all the freedom to change the material in the initial phase itself, not at the end of the design. So like that, by implementing the early simulation in the product development phase will not only help you to take the decisions faster, but also it will save the development cost and it saves the development time as well, and also increases the product knowledge earlier than the traditional way of doing the things, right? So here you can see the decision with simulation, early simulation. Let's say your engineers are doing the simulation, design engineers are doing the simulation uh, soon after creating the first design, right? Then based on that experience or based on the outcome which he's going to get from that particular design, he'll immediately change or modify the design and then release the final design as early as possible. But whereas here design decisions without simulation, right? Here you can see that as the design progress more, then you will be left with very lesser product knowledge and also the cost will go high. So how does early simulation help me now, right? So we also call this as simulation driven design. So what happens is if you implement the simulation driven design during your product development phase, then you can discover unimagined and innovative designs faster, okay, and without compromising on the performance, product performance, and you will be able to increase the design confidence while increasing speed to design delays. So if your design and simulation are in sync with each other, then you will be able to get the feedback on the design faster and you will be able to take the decision faster. And according to that, you will be able to uh, release the design for the manufacturing or production, right? So this is how it increases uh, uh, you know the confidence on the design and reduces the overall development cost and reduces the uh, launch of the product to the market as well. So how do we implement this now, right? The next question arises: how does it help me that if I implement simulation driven design or early simulation in my design phase? I mean, how to do that? So here, if you look at the traditional way of doing things, right? So the old ways, uh, your design engineer will create the first design today, and then he'll submit that design uh, to the simulation or CA engineer. By the time he starts and then done with some 50% of the simulation, the design have already revised. That is design 2 and design 3. But your CA engineer will be still working on the design 1 itself. So let's say again, after communicating all these updates, then let's assume that simulation engineer will get the updated design as design 4, and then while he is carrying out the simulation activity on that design 4, again the design engineer will update the design, and he'll create design 5th iteration. And then again simulation engineer will get pissed off on this, and then again, so this kind of activity keeps on going on and on and on in every product development phase, right, in every industry. And after, let's say, after design releasing the design 8, uh, the no, neither the design engineer nor the simulation engineer will have the confidence on whether the design is safe or working fine as expected, or will it be able to withstand the loads. All those things will be under question mark, right? So but let's say with simulation driven design approach, how does it help you to reduce the uh, time of the overall product development and also increases the confidence in your design? So let's start with the simulation zero activity. So the design one will get captured by the designer, and then the simulation will be done immediately after that. Then according to the results of simulation, then the modification of the design will be carried out, that is design 2, and then again the simulation will be carried out, and then design 3, and then simulation 3. So once, let's say I'm in maximum 3 or 4 iterations, then you will be all set to release the design for further activities. So now the question may arise from the simulation team that whatever the simulation results we are getting it from the designers are not, you know, uh, are not acceptable, right? So but here, the design engineer is doing the simulation activity just to see the critical areas and mitigate those critical areas, or deviate those or avoid those critical areas in the designs, not to exactly predict what is the stress value, what is the deformation value, right? So we cannot, consider the quantity which is coming out as a result from simulation, but we just have to see the how is it performing, whether the critical areas are avoided in that particular design. So that's what the approach here. So all designers uh, will have to carry out the simulation, so that it will increases their confidence to release the design for further activities. That is one thing. And also the work on simulation engineer will also get reduced. And the third thing is too many iterations can be avoided. Like in the first old way approach, to and fro, that is design one is getting transferred to CA engineer and then back to simulation guy, and then again new design coming from designer, and then again simulation will give the feedback to designer. So this keeps on going. But here, if the designer himself is doing the initial level of simulation, that is basic level of simulation during the designing a part, then that activity will reduce these uh, you know to and fro activities which will happen later in the stage, right? So this is how you can beat your competition by releasing the design early with more confidence and also with better design, right? So this is how you can reduce the overall product development time as well. If you know involve the simulation driven design approach with your design team. So historically, I mean, if we look at the history, the design department is again sits in a different room, and simulation department sits in a different room, and they work in silos. So once the design gets created, that will be transferred over to simulation, and then again the feedback will send back to designer, and again they'll modify the design accordingly, and the same goes on, right? So but whereas the new trend is like syncing up the design and simulation activities together. So design and simulation will go hand in hand so that the later to and fro activities can be minimized, right? So we talked about what is the way forward. Okay, so we learned that simulation driven design will help us in reducing the overall product development time and also increases the confidence on the design we are going to release, right? So now the question comes here is how Prolim can help you in doing this activity. So uh, we have a solution where the simulation can be done in the NX in the existing NX CAD environment. So I assume that you all are using NX CAD for your part designing, assembly designing, right? And once the design is done, then you will take out that maybe in step format or IGS format to the analysis team and then submit the job, right? But before that, we have capabilities of simulation in the NX CAD environment. If you're unknown, if you're not known about this, okay, so we can do the simulation in the same user interface which you are creating a part or assembly. Okay, so in this, what all capabilities we have? That is, first thing is usability, the single user experience for design and simulation. So like a design engineer need not to spend much time in understanding the physics, but he can just simulate some basic level of validation activities just to get the decision faster on the design part, right? So and then we have automation where let's say your analyst can capture what he is doing in terms of validation, and we can record that, and then the same recorded option can be given to the fresh engineer, so that he'll just follow the steps. So it's kind of step-by-step procedure, giving it to a fresh engineer. He just has to follow those steps, maybe 5 or 6 steps quickly, and these are all based on the templates what we create by capturing the process. And then the validation and scalability. So uh, when I said the simulation capabilities are available in NX CAD environment, so that is not just for simulation driven design or basic level simulation activities, but in the on the same platform we do have analyst level capabilities and also specialist level capabilities. So you can start all the way from component level or single part level till the assembly as complex as possible that can be analyzed, and the performance with respect to different physics can be simulated in analyst and specialist level. So let's take a closer look what exactly these three capabilities we are talking about. So first thing is the usability, right? So we have something called as designer simulation, where it is built into the same user interface of NX. Okay, so it's a single user interface between CAD and simulation. So he just has to switch from CAD environment to the simulation environment. So as I said, you can set three different roles in NX. So one is for designers, where he'll get some limited access to the pre-processing capabilities of a simulation. That is, let's say, if you are talking about discretization, that is meshing, he'll be uh, getting the access to create only 3D tetrahedral mesh and some controlling options to control the mesh, right? And analyst, he'll be having all the access uh, in terms of the meshing or element capabilities, that is 0D mesh, 1D mesh, 2D mesh, 3D mesh. All these things will be made available to the analyst. And then the reviewer is something like he's just worried about what is the result, what is the outcome we are getting from that particular analysis, right? So uh, some rules can be set just for post processing, that is just giving him the access for viewing the results what we have got from that particular simulation. So these are the three different roles can be set in NX interface, right? So what additional advantage you get if you compare this with any traditional uh, uh, s- tools or platform or technology, right? So we have a capability of associative analysis model. So what it means is, let's say you have designed uh, something like this, right? And after simulating, you have found that the location of this is causing some problem in terms of its performance. Okay, so let's change the location of this boss and ribs and all those stuff. So what we can quickly do is just by a single click, that is with the synchronous technology option, we can move the entire this part families to a different location, just a single click. And then the immediately the mesh also will get updated just by a single click of update option. So like this, you can do n number of iterations of what if scenarios, so that you will be getting to know that how does my design behave if I change this parameter, or if I modify this, or if I change the location of this uh, feature, right? So with that, you will be able to quickly iterate multiple options and then conclude something on the design part, right? So here, let's take one example wherein we start with the uh, CAD design. I mean, let's say the design is already available for us, and then we will, we will generate the mesh, and we will apply the loads and constraints which it is going to carry, and then we will solve it and review the results, right? And then we will quickly do some modifications in the design, and then we will see how quickly we can get the results out of the modified design, right? So let's take this is one part. Okay, so and you can see this is the same user interface of NX, right? So what we do is we switch from design application to design simulation application now. So here we can set up the name of this analysis and what type of analysis you are doing. So you will be given access to structural and thermal both, and that too on the basic level, that linear static and modal analysis and buckling analysis. So once you set up what type of analysis you are going to carry out, then you will assign the material. So I mean, you can assign the material here, or else if you have already assigned in your design, then the same thing will be taken forward. And now we are discretizing the component with the 3D tetrahedral element. So this is how one step automated option for generating the 3D tetrahedral elements. Once the mesh is created, then we will apply the boundary conditions. So let's fix these two locations, right? It depends on the application. So in this case, we are going to fix this at 4 locations, and we will apply some loads now, right? So either you can apply some force or pressure, depends on what type of force or what type of load it is going to uh, face in the field, and then we will give the magnitude and direction for that. So once we set up this, then we quickly say solve, and we will go to post processing, and then we will see the what is the displacement it is causing because of that constraint and loading condition, and where exactly it is deforming more, right? So accordingly, and uh, uh, based on the expectation of the behavior of the part, we can do some modifications in the design. So now you are not even going back to the CAD environment. Simply, being in the simulation environment, you have all the access, almost all the access of uh, uh, the modifying feature options like synchronous modeling technologies, and this is how we can quickly move these features from one position to the other position. Now you can quickly say update, so the mesh also got updated as per your modified design, and then we quickly come back to the sim, and then we just say solve this, right? So what we do is we copied that, and then we are solving it, because we will be having two results, that is older results and the newer results, so that we can compare it well. How was it and now how it is? So now we can go to the post processing and see what is the deformation it is causing with older design, and what is the deformation we are getting with the newer design. So this is how you can see it is almost cut down by 50%, right? Initially it was 0.75, uh, and but here what happens is it again depends on what modifications you have done. So in this case, the stress or the deformation concentration area has been you know changed, right? Earlier it was at critical region, now the critical region has been shifted to some other location where there is a enough strength to withstand this, right? So this is how you can quickly perform the simulation within NX, and do the modifications accordingly before sending it to the simulation engineer, right? So as I said, this is being a single interface for both design and simulation. Uh, it will give you the better productivity in terms of the product development, and perform what if scenarios very quickly, and then get the design verified with the different conditions, and then it reduces the overall product development time by making simulation concurrent with the design. So this is how many customers have got benefited because of this new approach, that is simulation driven design or early simulation in your product development phase. So there is a case study where they have talked about, initially it used to take, let's say, a week, days together or weeks together, but with implementation of simulation driven design in their product development, they are able to cut down the overall development cost in a significant way. And uh, they are very happy about it now because they are able to get the more confidence on the design, and they are able to cut down the overall cost as well as time, development time of the product, so that they can go to market very quickly compared to their competitors. So second thing is the automation. So let's say in your organization you have a newly appointed engineer who does not know much about even the basic simulation, but there are some engineers who are doing design as well as the basic simulation which we did just now, right? So in that case, how do we, let's say the project's deadlines have come and very close by, and we have to you know uh, validate, or we have to submit our final design to the simulation team so that they can conclude on the product performance. So in that case you will have to you know uh, use all the resource which are available, right? So in that case what we can do is we can quickly create a template for fresh designers who are going to use that as just a wizard based or template based approach, and they can quickly do the simulation and give the result to you. So how do we do that? Let's get into that more in more details. So you can easily capture and automate and deploy simulation process in the CAD environment. So whatever steps we did in our last demonstration, everything can be captured in terms of the process. But only thing is you just have to give some inputs. Let's say you are applying some pressure, right? So you have to select the phase on which you want to apply and what is the magnitude. So likewise, the templates will get created to automate the process. So this will reduce the training cost for multiple and solver specific tools, and this being a common user interface and technology used by design and CA team, which will help you to switch the different resources between different projects. So, as I said, what simulation engineers or the design engineers who have got experience on the simulation now, they can quickly create some templates and give it to the freshers so that they'll just follow it and get you the uh, uh, design validated, right? So let's take one more demonstration on this. Here what we have done is use an automated simulation process captured with journaling and NX Open. So we can capture the entire process either through journal or macros, and those journals or macros will get stored in one of the scripting language, maybe Python, and the same thing again you can replay it if you want to implement the same process with different part or assemblies, and then designer performs routine automated simulations. So let's take how does this work, right? So here, this is an exhaust manifold of a, let's say, automotive vehicle, and what we are trying to do here is we are just trying to capture the flow physics. We want to simulate the CFD. As you know, that CFD is a very specialist level activity which are done by the specialist or analyst, right? So see here, you can see the intake manifold analysis. It has five options which needs to be followed, which are captured through the process automation, and which are captured through the process automation. Uh, and then we can simply ask the fresh engineer to follow these steps. So initially what he did is he just created the step one. He selected the step one, that is creating NX flow FEM and simulation part, and then he extracted the fluid domain, And third step is creating the plenum test chambers, and then he meshes the fluid domain, and then now he sets the flow physics for CFD simulation, and now he gives some input and output selections so that the boundary conditions can be applied on top of them. So once we solve this, then you will be able to visualize the results so easily. So here you don't need a CFD expertise. You don't need uh, you know you don't need to know much of the options which are used by our specialist or analyst. So you're just following step-by-step procedure, which is captured through the automation in NX Open, and then you will be able to predict the product performance uh, quickly, right? So you can capture knowledge of simulation experts, enable novices to carry out routine tasks with minimal training. So you don't need to spend much time and cost in training the new resources, and then maintain high level of confidence in outputs. So here, what kind of automation you have captured that can be kept secret, and I mean, and also confident, right? So this is how even many customers have got benefited just by doing this kind of basic automation, and helping their design engineers to validate the designs faster at the initial phase itself. So you can see the results. The 40-hour iterative analysis process drops to 15 minutes. Where is 40 hours and where is 15 minutes, right? So this is how, I mean, this is what the benefits customer or you will get if you implement the simulation driven design or early simulation in your design process. So the SimCenter and NX toolset is world-class functionality set by the president and CEO of Design Association Associates. So again, there are so many customer case studies who have got benefited just by implementing this in their day-to-day CAD creation activities in NX. And then the validation and scalability. So when we talk about the validation, so you can deliver the visibility across the enterprise. So it can be connected to your data management and all those things, and you can manage the data that is getting generated by the the these kind of simulations, and also you can see that whether to release or not, whether the simulation has failed or whether the simulation has passed. All those things can be captured, and then finally the topology optimization. uh, uh, it's like, let's say, once the design the basic design validation and design finalization is done, then you can also work on the topology optimization, where you're trying to remove some material so that the cost of the product can be reduced, and also weight of the product can be reduced, but yet maintaining the same performance of the part, right? So no, we are not compromising on the performance, but still we are trying to reduce the cost of the part so that it can be more competitive in the market. When we talk about the scalability, right? So in any simulation department, or in any new product development team, there will be three types of uh, simulation users. That is, it all starts with the designer level simulation, which we are talking about today, and then the analyst level. So designer simulation is something like they'll be working on the single part level, right? And the analyst level is like assembly level analysis, as the different complexity gets involved, and then high-end multiphysics simulation, where the, let's say, the dynamic simulation or durability simulation or thermal, CFD, multiphysics simulation, or electronic system cooling simulation can be uh, uh, evaluated. So this is how you can scale up the NX and SimCenter 3D capabilities on the same NX platform, starting all the way from part level simulation to high-end multiphysics simulation with the same user interface without changing the user interface from one platform to another platform. So as we discussed initially, the current trend is simulation and design both getting together and syncing up together. And here you can see that uh, SimCenter 3D capabilities have uh, captured all the physics very well, starting all the way from structures, dynamics, durability, composites, thermal, CFD, flow, acoustics, right? Electromagnetics and NVH. All those stuffs can be simulated with SimCenter 3D, and also the multiphysics, and finally the optimization of the part. And both of these are built on NX platform. So if you want to, let's say, product do the product design, industrial design, visual analytics, documentation, all those things with respect to the design capabilities can be done in the same user interface. And also all these simulations like structures, motion, thermal, CFD, durability, everything can be done in the same NX platform. So takeaway for today's webinar is when you are trying to start with the concept designing, right? So if you implement the simulation driven design at the initial level itself, then you can discover the better or best design, which is even unimagined design, right? So you can explore different designs faster and also take the decision as early as possible. And then when you get into the detailed designing, then you can increase the design robustness while speeding development process. So we uh, saw that how the simulation, basic level simulation, and also uh, the automation we can capture on the process side will help us to get the design validated quickly, not on the quantitative side, but on the risk side or the critical area side, or the how well the design is suitable for the particular loading conditions that can be evaluated in the earlier phase itself, right? And then finally the validation, where we talk about you can do the simulation starting all the way from part level, assembly level, and then the specialist and analyst level kind of stuff, that is the multiphysics scenario can be involved in your studies, and then you can quickly validate your designs to meet the product performance and also the cost requirements, where you are trying to reduce the cost but yet increasing its performance, right? So this is how the simulation driven design will help you to beat your competition both on cost as well as the product development time, including the launch of the product to the market. So I'll end my presentation now. So if you have any questions, then I would be happy to answer to those questions. Jake, any questions for me?
No, I think we're all good. Great job, and appreciate you presenting today. And we will be sending out an email with the link to watch and share with friends and colleagues as soon as we get that up on our YouTube page. So I think that's about it, Amit, and thank you. And I will send you the link when we have it.
Okay. Thank you, Jake. thank you everyone for your patience and spending your 60 minutes of time with us today. Thank you
Yeah,
once again.
thanks, Amit.